Good morning, students. Myself, Vijay Shankar from BC Department, Chevron Engineering College. Today, we are going to discuss about the properties of Fourier series, the third revision. In the previous classes, we completed the 5 properties. The last 2 classes. In today's class, we discuss about the convolution in time domain. Convolution in time domain. The last 2 classes, the properties of the Fourier series we completed, that is a Fourier series, the linearity property, time shift property, and frequency shift property, scaling property, and the time differentiation property. Totally the 5 properties of the Fourier series we completed. The linearity property of Fourier series, time shift property of the Fourier series, frequency shift property of the Fourier series, and scaling property of the Fourier series, and also the time differentiation of the Fourier series. Today we are going to discuss about the remaining Fourier series properties, that is the convolution in time. Convolution in time. Before going to discuss about the convolution in time, the property of Fourier series, you have to know what is the convolution. What is a convolution? And what is the formula you have to use for the continuous time signal and the discrete time signals. Okay. So convolution integral. Convolution integral. Convolution integral. This is for the continuous time signal. For continuous time signal, we are using the convolution integral. For discrete time, we are using the convolution sum. Convolution sum. With convolution of is an asterisk, the convolution symbol, and y of t is equal to, and here the discrete time function, the x of n, the variable is changes here, the convolution of y of n is equal to, here we are using the sum of n is equal to, not the n here, k is equal to minus infinite to infinite, and the convolution integral minus infinite to infinite, or you take it as a t, integral t, x of tau, y of t minus tau, d tau. Okay, and here the sum of k equal to minus infinite to infinite, x of k, y of n minus k. But also, this equation can also written as sigma k is the sum of k is equal to minus infinite to infinite, y of k x of n minus. So both are the same. Okay, because the convolution obeys commutative property. What is the commutative property saying? AB is equal to BA. AB is equal to BA. So I'm interchanging x as a y here and y as x here. So the commutative property is saying AB is equal to BA. Understood? So the convolution obeys the commutative property. We can also use the x of k, y of n minus k, or the y of k, x of n minus k. And this is the equation we got from the actually the causal and the non-causal signals. So the continuous time signal and the discrete time signal, again it is classified as periodic, non-periodic, even and odd signals, deterministic and the random signals. Okay. Energy and the power signal. The another we have the causal and the non-causal signals actually. Causal and non-causal signals. So what is a causal and non-causal signals? First of all, causal. Suppose if I am taking the two equations, causal means simply you can say h of n is equal to 0 for n is less than the 0 value. Means h of for negative values for negative values of n, the h of n, the unit impulse signal, the h of n is equal to 0. When this condition is satisfied, the causal signal, causal, okay, means h of n, h of n minus k, not the n, it is a k value, x of k, h of n minus k, and so on. In this, the sum of k is equal to minus infinite to infinite. We can expand this function from the minus infinite to infinite. The negative values of k, here it is a k actually. The k is h of n is equal to 0 for n is less than the 0. Or we can also write it as sum of k equal to minus infinite to infinite h of k, x of n minus k. Now I can expand these functions so on, so on, so on. H of minus 1, x of n minus of minus 1 becomes is a plus 1, plus the next value, if I am taking the h of 0 as a k is equal to 0, x of n minus 0, and next function, if I am taking the h of 1 as a k is equal to 1, x of n minus 1, plus so on, is a function. I'm taking all the negative values. I'm showing here only the minus 1, 0, and 1. Substituting the k is equal to minus 1 here. H of minus 1, x of n minus of minus 1 becomes a plus x of n plus 1. Plus h of 0, x of n minus 0, plus h of 1, x of n minus 1. When we can switch a causal, it depends upon the present inputs and the past inputs. What is the input here? X is the input. X is the input. If X is the input, X of n is the input. x of n is a present. X of n is a present. And x of n minus 1 is a past. And x of n plus 1 is future. Okay. So when we can call it as a causal, it depends upon the present input x of n, and it is also depends upon the past inputs of x of n minus 1. It is not depends upon the future input. So to get the negative values, all the negative values becomes a 0. The input is not at all equal to the 0 because here the input is there. The previous, before the value is a h of minus 2. H of minus 2 and the x of n plus 2. Okay. And here the h of minus 3, x of n plus 3. Means towards the left side up to the minus infinite, the input value is future inputs only. X of n plus 1, n plus 2, n plus 3 and so on. So the input is not at all equal to the 0, but these terms to become a 0 value, so when we can substitute the h of n is equal to 0 when n less than the 0 value. See here, when n is equal to, I'm taking the minus 1, h of minus 1 is a 0. When n is equal to minus 2, h of minus 2 is a 0. When n is equal to minus 3, h of minus 3 is a 0. So all the future inputs with the multiplication factor of h of n is equal to 0 for n less than the 0 values is a causal and the non-causal. If this condition is satisfied, we can call it as a causal. Not satisfied means the feature, it is also depends on the feature inputs, non-causal system. Okay. Coming to here, in the convolution in time, we are using the convolution integral formula. What is the convolution integral formula? The x of tau, y of t minus tau d tau. Okay, let's go the proof of the convolution in time. Convolution in time. Okay. What is the statement saying? If x of t is a Fourier series x of k and y of t, the Fourier series y of k, then the convolution of z of t is equal to the convolution of the two signals x of t with convolution of y of t is a Fourier series of Fourier series z of s is equal to x of k into y of k, x of k into y of k. So let us go for the proof. Okay. It is saying that z of s is equal to z of s is not the s, sorry. It is not the s, k value, my dear students. z of k is equal to 1 by t integral t. Listen carefully, my dear students. 1 by t, the integral t, z of t, e power minus jk omega naught t is the formula for analysis equation. Okay, by the exponential Fourier series analysis equation. So what is the z of t here? So that is equal to 1 by t, the integral t, z of t as a convolution between of x of t and y of t, e power minus jk omega naught t dt. Omega naught t dt. I can represent x of t, the convolution of y of t, as convolution integral 1 by t, the integral t, and this is also the 1 by t, the integral t, x of tau, y of t minus tau, d tau, as a formula for x of t with the convolution of y of t, into e power minus jk omega naught t dt. Okay, my dear students. Now bring all the tau terms and the t terms separately. So 1 by t, the integral t, x of tau, d tau. Another integral I am using here, 1 by t, the integral t, y of t minus tau. Here also the t is there, e power minus jk omega naught t dt. Separate all the here, the t is there, this also the term t and the t. Now you can see here, these are the two functions we got from the above equation. It is just look like as a time shift property. Instead of x, here the y is there, yt minus tau, t minus t naught is there. T minus t naught, instead of t naught here the tau. Or otherwise, you can assume t minus tau is equal to m, as usual what we did in the time shift property. Or otherwise, by using the time shift property, you can replace this total in the parenthesis as e power minus jk omega naught t naught, actually instead of t naught here the tau into dt, not the dt, y of k. Otherwise, without knowing that t minus tau is equal to m, we can assume, apply the derivative on both sides as the tau is a constant here, dt is equal to dm. Dt is equal to dm. And what is t here? T is equal to m plus tau. T is equal to m plus tau. Replace these values in the second parenthesis what we have here. I will show in the next page. And z of k is equal to, as of 1 by t, the integral t, x of tau, d tau, as a first parenthesis, and second parenthesis have 1 by t, the integral t, y of t minus tau, the t minus tau replaced as m, e power minus j k omega naught, t as t plus tau, not the t plus tau, m plus tau, m plus tau, and dt as a dm. Okay, my dear students. So the t minus tau I replace with the m here, and t t as a m plus tau, and dt as a dm. Okay, is totally within the parenthesis, is equal to 1 by t, the integral t, x of tau d tau, as of the one function here, and this one is a 1 by t, integral t, y of m. I'm separating the two functions here, then the power as a plus is there, e power minus j k omega naught m into dm. Okay, I use this function as a one function, and the remaining factor here, e power minus j k omega naught tau, e power minus j k omega naught tau. See, this total function is similar for the analysis equation. What we have, x of k is equal to 1 by t, integral t, y x of t e power minus j k omega naught t dt. Instead of t here, the m is there. Instead of x here is a y. So you can write it as a y of k. 1 by t, integral t, x of tau d tau as one function, and this total function will get as y of k as a Fourier series formula only, into e power minus j k omega naught tau, and rewrite this function again, is equal to 1 by t, the integral t, x of tau. So bring this function is inside, e power minus j k omega naught tau and d tau. Keep it as one function, and y of k. Now you can observe this function is also similar to this analysis equation, 1 by t, the integral t, x of tau e power minus j k omega naught tau d tau. Instead of t, here the tau is there. Here, instead of t, m is there. So y of k. Here the x, it becomes of x of k. The x of k into y of k. F of k into y of k, as z of k is equal. Z of k is equal to, we got x of k into y of k. What the, this is z of k is equal to x of k into y of k. Means the time is convolution time. The time is convolution, product in frequency. Product means multiplication. The time is convolution in the two signals, the product of the frequencies of the two signals. After applying the Fourier series in between, the convolution in time is a very, very important property. To see that, convolution. So here also you can observe z of k is equal to 1 by t, the integral t, the integral t, z of t e power minus jk omega naught t dt, and 1 by t, the z of t have to take as the convolution between of the two signals, x of t, y of t. So x of t with the convolution y of t e power minus j k omega naught t dt. What is the convolution of x of t and y of t? Formula is x of t, the convolution of y of t, 1 by t, the integral, 1 by the integral x of tau y of t minus tau d tau. So there is no 1 by t here, my dear students. Okay. This convolution is performed over one period for periodic signals. This convolution is performed over one period for periodic signals. And substituting the x of t with the convolution of y of t here, this formula. See, z of k is equal to 1 by t, the integral t x of tau y of t minus tau d tau e power minus jk omega naught t dt. Interchanging the order of integrations, I'm taking the 1 by t, the integral t x of tau as a tau functions, remaining the integral t y of t minus tau e power minus jk omega naught t dt and the d tau. You can write here, it is directly the d tau. Okay. See, they, as usual, by substituting t minus tau is equal to m, therefore dt is equal to dm. Since integration is over one period, this substitution will just shift the integration limits, but it will be again over one period only. Hence, we can write it as z of k is equal to 1 by t, the integral t x of tau, and the integral t minus tau is equal to m here, e power minus jk omega naught, the t, now it is tau plus m, or m plus tau d tau, and the dt is equal to dm. Okay. So 1 by t, the integral t x of tau, integral t y of m e power minus jk omega naught dm tau e power minus jk omega naught m d tau and the dm. So y of m e power minus jk omega naught dm as a y of k, and 1 by t, the integral t x of tau e power minus jk omega naught tau d tau is a x of. So actually we have only the 1 by t, my students. I explained here. I substitute the 1 by t. There is no any 1 by t for here. 1 by t. There is no any 1 by t in the convolution. So remove that 1 by t. Then the second page also, remove that 1 by t here. 1 by t. So this function is y of k. And here there is no any 1 by t, and here there is no any 1 by t. To keep the 1 by t here, 1 by t, and multiply the t here. Multiply the t. T. This function has x of k and y of k. There is a t is also there. T into x of k, y of k. You have to prove that the t into x of k, y of k. T into x of k, y of k. There is no any 1 by t, the function in the convolution formula. X of t, convolute the y of t is only integral t x of tau y of t minus tau d2. And this t, you can multiply here the 1 by t and the t function. Understood? So final z of k is equal to taking of 1 by t, the x of tau, e power minus jk omega naught tau d tau as x of k, and integral tau, integral t, y of m e power minus jk omega naught m dm, and if there is 1 by t, then only it is a y of k. There is no 1 by t, keep that here the 1 by t, and multiply the t here for this total function. Okay. Then the t into x of k, y of k. Z of k is equal to x of k, y of k into t. Okay, my dear students. So here you have to prove the z of t is equal to x of t with the convolution of y of t. Apply the Fourier series for the time convolution or the convolution in time. The frequency becomes z of k is equal to t into x of k, y of k. T into x of k, y of k. So very important property.